In the last lectures, we have studied about the number systems. So, in general, for the computer applications, we have three basic types of number system. First is your binary, octal, and hexadecimal. So far, we have studied about how to convert any particular number into another number system or a number base, and how to take the complements. So we have two type of complements. One is your radix complement. Another one is your diminished radix complement. That is, if I talk in terms of binary number, so one is 2's complement, another one is 1's complement. So, in the last lecture, we have discussed how to subtract two numbers using ones or two's complement. We have done some of the examples. Now, the next topic here today we are going to discuss is the signed binary numbers. So far, what we have discussed, we haven't discussed about the sign of the number, if the number is positive or number is negative. Now, the sign magnitude number representation represents a number with its magnitude as well as its sign. So, we have two types of number, either it is a zero, that is a null number, or we have a positive number and a negative number. Suppose I have to represent 5. So, with the 3-bit representation, when I convert 5 into the binary, then it comes to be 101. Are you getting my voice now?
Yes, sir.
Okay, fine. So the 5 is represented as 101. So we never discuss about what is its sign. We say we talk about only the magnitude. Now in today's lecture, we are going to discuss then when a number is a number is with sign, then how to represent that number, and the representation is known as signed binary numbers and the signed binary representation. So let us discuss what the signed binary numbers are. The positive integers including 0 can be represented as unsigned number. But to represent a negative integer, we need a notation for negative values, because when we are using in computer, we need not to put a negative sign. So we are in the such that there should be a system, so that in the terms of binary, we have two digits only, either 0 or 1. So there is a way how to represent a number with the help of zeros and ones, so that when I look into the number, then I can directly identify that it is either a positive number or a negative number. So we need a notation for the negative values. And in ordinary arithmetic, a negative number is indicated by a minus sign, and a positive number is indicated with a plus sign. That is in general, which you are studying from class 1 to 12 or in the first year so forth. When you are not, when we are not talking about the computers. So due to the hardware limitations, computers must represent everything with binary digits, commonly referred to as bits. When we are talking about the binary number, then each digit is known as bits. So each one is a single bit. If I represent 10, that represents 2, that is known as 2 bits. 4 bit is equals to nibble, 8 bit equals to half word, so 8 bit equals to byte, 16 bits is half word, and when we are representing a bunch of 32 bits in a array, then it is known as a word. So these are the representations in the binary number. So it is customary to represent the sign with a bit placed in the leftmost position of the number for binary numbers. Means if we have a system with 8-bit computer, then the leftmost, that is the MSB, will represent the sign bit, and rest of the 7 bits will represent the magnitude. That is the process which we are going to adopt. The convenient is to make the sign bit 0 for positive number if the leftmost bit of a number system representation is 0, so we say that this number is a positive number. On the other hand, if the leftmost bit is 1, then we say that it is a negative number. So the representation is clear. Either we have to represent number with 8-bit, 16-bit, 32-bit, and in the current scenario, what computer you are using, or even your laptops, even your mobiles, these all are 64-bit processor. So that means 64 means if we give the range of the bits in your register where the data is stored, then it will start from 0 to 63. That is total 64 bits, and the 63 bit that is the leftmost most significant bit will represent the sign, and the rest 0 to 62, that is 63 bits, will represent its magnitude. That will be much clear when we are going to do the example. Now we should realize that both signed and unsigned binary numbers consists of a string of bits when represented in a computer. So always data is stored in your hard drive, or in your RAM, or in your cache memory, or in your processor. These are called the registers. The register is nothing but it is a sequence of the bits where the data is placed. So we need not to put a negative sign or a positive sign in the hardware. With the help of zeros and one, we'll store the data that it will be directly shown to the computer, or it will directly known to the computer that it is a positive number or it is a negative number. The user determines whether the number is signed or unsigned. So जो scheme है, that will always primarily will be known that the data is stored either in signed magnitude or is in unsigned magnitude. So that command will be given to the system or to the user. The data stored is in which form? Either it is a signed magnitude representation or unsigned magnitude representation. When the data is of unsigned magnitude representation, then there is no need of putting any 0 or 1. We have to represent the data with its magnitude only. When we are representing the number with signed magnitude, then the leftmost bit will be 0 for positive number and 1 for the negative number. Now, if the binary number is signed, then the leftmost bit represents the sign, and rest of the bits represent the number. That is our representation module, which we are going to represent signed binary numbers. Now take an example of bits. It is represented 0, 1, 0, 0, 1. That is a number. I hope that all of you please convert this number into the decimal number. What its value exactly is. So how we will convert it is, we calculate the coefficient position, and the coefficients are 0, 1, 2, 3, 4. So it is 0 multiplied by 2 to the power 4 plus 1 into 2 to the power 3 plus 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. So these zeros coefficient term will be 0, and it will be 8. 1 into 2 to the power 3 is 8. 1 into 2 to the power 0 is 1. So 8 plus 1 is 9. So when with the knowledge so far we have gained or we have discussed in the previous lectures, so I may say that this number represents a 9. So it can be considered as 9 for an unsigned binary number. If I say that I am just representing a string which consists of 0, 1, 0, 0, 1, and I am not aware about the scheme that which we are using here, then it is nothing but it is a 9. Now, or I can say when it is a signed binary number, it is plus 9, because the leftmost bit here, it is 0. So 0 represent a positive number in the signed binary. So I may say that when it is a unsigned binary, it is 9. When it is a signed binary representation, it is plus 9. Now take another example. If I say that a number is 11001. So when I convert this number into binary, then it will be 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. So here it is, this 1 is equivalent to 1, this is 8, this is 16. So 16 plus 8 plus 1. So I think it should be, when you convert this number into binary, it must come equals to 25. When I can interpret as 25 when it is an unsigned number, or if it is a signed number, signed binary, so this one represents, leftmost one represents that it is a negative number. So I put a negative sign and convert rest of the bits 1001, that is equals to 9. So in signed by a magnitude representation, it must be -9 when considered as a signed magnitude representation. So here is the difference. The scheme in which the numbers are stored in the computer will be well known to you, users, and the computer. So when a computer looks into a number or in a string, it first checks the leftmost bit. If it is 0, the number will be converted with the rest of the bits and it will be positive number. If it is 1, then the magnitude is the rest of the bit and the computer will interpret it as negative number. So any doubt till here what we are going to discuss?
अरे -9 होगा, -25 होगा वहाँ पे.
नहीं, this will be -9 because this one represents minus and this rest of the bit represents 9. So that means it is -9.
Yes sir, yes.
And in the previous case, this is 0, 0 represents positive and the rest of the bit represents 9. So it is +9. Fine? Okay. Now, there should be no confusion in identifying the bits if the type of representation of number is known in advance. So it will be known in the advance that I represent 11001, then I will say that it is a sign magnitude representation. So what will you do? You will look into the leftmost bit. If it is 0, then number is positive. If it is 1, then number is negative, and the rest of the bit will represent its magnitude. That's it. You have to do nothing with it. You will be very well known that which type of representation we are using in computer. Now suppose the representation of a signed magnitude number is referred to as signed magnitude convention. In this notation, the number consists of a magnitude and a symbol either plus or minus, or a bit 0 for plus and 1 for minus. This plus and minus can be represented in your paper and with the help of your paper and pen for representing the sign. When we are going to manipulate the data in the computer, then we have to represent it with the bit. So for the positive, we'll write 0, and for the negative number, we will write 1 in the most significant bit, or we can say the leftmost bit of the string. Now, when arithmetic operations are implemented in a computer, it is more convenient to use a different system for representing negative number, referred to as signed complement system. So here the first what we have discussed, the first way is to represent with the sign bit. Leftmost bit is sign bit. If it is 0, number is positive. If it is 1, then number is negative. Now there is another way how to represent the number in your computer with the complements. So we have studied there are two type of complements. In case of binary, it is either 2's complement or 1's complement. So what we can do, we can represent a positive, a positive and negative number with the help of coefficient complements also. Now the signed complement system we are going to discuss here. In this system, a negative number is indicated by its complement. The signed complement system can either use a 1's or 2's complement, but the 2's complement is most commonly used in your computer system. That I'll discuss it later on when we compare both 1's complement and 2's complement representation. Then I'll discuss it in the detail. Sorry. Consider the number 9 represented in binary with 8 bits. So minimum size of your processor is 8 bits. So we'll represent all the numbers in 8-bit representation. So what is 9? So plus 9 is represented. 9 is 1 0 0 1. That will be in the leftmost part, and the rest of 4 bits are 0. As we are representing plus 9, then the leftmost bit is 0. That is your sign magnitude representation. So we represent plus 9, and the string comes to be 0 0 0 0 1 0 0 1. So it is a signed magnitude representation. Leftmost bit will be 0 because we are representing positive number. Now, while there is only one way to represent plus 9, there are 3 different ways to represent minus 9 with 8 bits. And the first representation is the sign magnitude representation, in which what we do, we just change the leftmost bit from 0 to 1. Then the number becomes minus 9. So here the leftmost bit is 1, and this magnitude represents 9. So it is minus 9. So when I write 1 0 0 0 1 0 0 1 with the sign magnitude representation, then the number is minus 9. Whenever I or computer examine that the leftmost bit is 1 in the sign magnitude representation, it says it is negative, and the rest of the 7 bits, these 7 bits will represent its magnitude. So I'll directly compute its magnitude by expanding the coefficients multiplied by its weight. Now, if I take the 1's complement representation, what I do, I just take the 1's complement of plus 9. If you look, you can solve it. When you have to take the 1's complement of plus 9, it should be, first you have to represent number in 8-bit string with plus 9. Then 1's complement will be 1 1 1 1 0 1 1 0. So when a positive number is represented by its 1's complement, it represents its negative number. That is, magnitude is negative. What we are doing in case of the subtraction, when we are performing x minus y, every time we take 1's or 2's complement of the y, then it represents minus y. So x is added to the 1's complement, that is, x is subtracting from the y. That was the scheme behind that. So here the 1's complement will be 1 1 1 1 0 1 1 0. So it will represent here. Now in this way, when I take the 1's complement of positive 9, it will represent minus 9. And similarly, if I take the 2's complement of plus 9, it will be minus 9. So here is the 1's complement of 9. Then add 1 to this 1's complement, it will represent the 2's complement. The 2's complement, I just added 1, so it will 1 plus 0 is 1, 1, 1, the rest of the bits are same. So these are the 3 different ways how we can represent a number in signed magnitude representation for the negative number. For the positive number, 1's and 2's complement are the same as the plus 9. That should be kept in mind. We can never take the 1's and 2's complement of the positive number, because for the positive number in the signed magnitude representation, 1's and 2's complement are same as plus value. Now take an example. I will discuss an example so that you can solve in your copy. Then we'll move on. Now here we can conclude that in sign magnitude, minus 9 is obtained from plus 9 by changing the sign bit in the leftmost position from 0 to 1. So what you need to do, you have to represent number in 8-bit representation. Keep leftmost bit positive, so 0 for positive. Now when you are converting this number into negative number, the leftmost bit will change from 0 to 1, and the rest 7 bit will be same. So your number will be converted into negative value. Or in signed ones complement, negative number is obtained by complementing all the bits of +9, including the sign bit. We take the ones complement of the string of 8 bit, its ones complement, then it will represent its negative value. Because when we take the ones complement, the leftmost bit, sign bit, which was 0 initially, will be automatically 1. Now in signed twos complement, -9 is obtained by taking twos complement of the plus positive number, including the sign bit, what we have done in the previous example. Now we can conclude that the sign magnitude system is used in ordinary arithmetic, but is awkward when employed in the computer arithmetics, because we have to take we have to look into the number, we have to change its bits, positive and the negative. Therefore, the signed complement is normally used in your computer. Now, the ones complement represents some difficulties as it's seldom used for arithmetic operation, and the signed binary arithmetic deals more with twos complement in representing negative number. So hereafter, when we are not asked to represent a number in different negative sign magnitude representation, if you have to represent a number in sign magnitude representation, then it is more convenient than we use twos complement of the positive number. What we do, we just represent the number in 8-bit string, keeping its most bit 0, then taking its twos complement. And twos complement, what we do, we take ones complement, add 1 to the ones complement. Now I suppose one by one you all start doing this example. Now represent -13 in signed magnitude with 8-bit representation. So what we have to do, we have to represent -30 in signed magnitude with 8-bit representation. So what you have to do first convert 13 into binary. Do it yourself, then I'll show you the results. Convert +13 into binary. And the process is 13 is divided by 2, 6 is the result, 1 is the remainder, then that is the first coefficient. Do it yourself. So +13 is 1101. Am I right?
जी sir.
Okay, fine. Now the +13 will be represented in 8-bit. So what I have done, because 13 is of 4-bit, तो हमने क्या किया, 4 बिट में zeros लगा दिया. तो number +13 is 0 0 0 0 1 1 0 1. That is the representation of +13 in 8-bit register. Now convert this 13 number with sign magnitude representation. What you have to do, you just change the leftmost bit from 0 to 1. Then the rest 7 bits will be same. The number will be 1 0 0 0 1 1 0 1, and this will represent your sign magnitude representation. मोहित सैनी क्या चल रहा है अभी ये?
सर ये मेरे नाम से कोई और आया, मैं नहीं हूँ सर ये.
Okay, fine. And the sign magnitude representation, you have to just change the leftmost bit. Now, when we take the ones complement of the +13, it will represent -13. So here I have represented this +13 is converted with the help of ones complement. Then it will come to be 1111001. So its ones complement will be 11110010. So here is your minus 13 representation of 13 with the ones complement representation. Similarly, when you have to represent it with the help of twos complement, so you have to take just the twos complement, and its twos complement will be just add 1 to the ones complement. It is 11110010. So here with the three methods, we can represent a negative number. It may be sign magnitude representation, it may be ones complement representation, it may be twos complement representation. Now there are some examples how to represent a 3-bit number. So the range of the 3-bit number is 0 to 7. So 0 represented by 000 and 7 is represented by 111. When we look into the table, for the positive number from +7 to the 0, we see that the leftmost bit is 0 and start with 000, that is 0, 001, 1, 010 is 2, 011 is 3, 100 is 4, 101 is 5, 110 is 6, 111 is 7. So leftmost bit is 0. Now when we have to represent -0, so what we do, magnitude is same, we have put a positive leftmost bit is 1. So 1000 is -0, 001 leftmost bit is 1, it will be -1 and up to -7. So now here you can see that from 0 +0 to +7, the ones and twos complement are the same. The beauty of the why we use twos complement, that for the twos complement +0 and -0 is same, but in case of ones complement +0, and in the sign magnitude representation +0 and -0 both are the different things. That's why we use twos complement over ones complement representation and the sign magnitude representation of the negative numbers. That's why we use only twos complement.